A very good morning, students. So today we are going to discuss the problems related Gauss divergence theorem. In the previous video, we have discussed the Gauss divergence theorem. So now we are going to discuss the problems related to Gauss divergence theorem. So there are two kinds of problems are there. So one is evaluation of Gauss divergence theorem, and another one is the verification of Gauss divergence theorem, like Green's theorem. So in Green's theorem also we studied evaluation and the verification, right? So here are also the two kinds. So first I have taken the evaluation. Okay. So I hope you are all go through the video Gauss divergence theorem, right? Okay. So first I have taken the evaluate. So evaluate Gauss divergence theorem, you know, right? What is the statement? Okay. So this is the statement, right? So if f is a continuous differentiable vector point function and v is the volume bounded by a closed surface, then the double integral under the surface S f n into ds is equal to double integral under the v volume divergent of f into dv. Right? This is the statement of the Gauss divergence theorem. Keep it in your mind. Okay. Okay. So we are going to evaluate the first problem. Evaluate using the Gauss divergence theorem. F is equal to, this is the given function, and S is the total surface of the rectangular parallelepiped bounded by the lines, bounded by the planes. X is equal to 0, y is equal to 0, z is equal to 0, and x is equal to 1, y is equal to 1, and z is equal to 3. So this is our given problem. Okay, we should evaluate, no need to verify. Verify means we have to show that LHS is equal to RHS, means double integral under the surface S f into n into ds is equal to triple integral under the volume divergent of f into dv. We should show that these two are equal for the verification. For evaluation, you can take any one of the thing and you can find out the value, right? So first, we should evaluate the divergent of f. For that, we want the given function. This is the given function f. By using this f, we have to find out the divergent of f. So, how to find out the divergent of f? So, thus f can be represented as what? f1i plus f2j plus f3k, right? So, divergent of f is what? Dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So here f1 is what? 2xy, f2 is y2 yz square, and f3 is xz. So by using this, I am going to find out this divergent of f. Dou by dou x, we are partially differentiating with respect to x. So here 2y is a constant. So the differentiation of x is 1. So 2xy, partial differentiation with respect to x means we will get 2y, right? So here we are differentiating with respect to y means here z square is a constant, differentiation of y is 1, so we will get z square. And with respect to z means x is a constant, the differentiation of z is 1. So the divergent of f we got 2y plus z square plus x. Okay, so triple integral under the volume divergent of f into dv is equal to, you see they have given the planes. Our x value varies from x is equal to 0 and x is equal to 1, and y value varies from 0 and y is equal to 2, and z value varies from 0 to 3. So 0 to 1, 0 to 2, 0 to 3. So all are constant limits, so you can write anything first. Okay, here I have taken the first is x, y, z. Okay, so the divergent of f value is what? 2y plus z square plus x. Okay, this is what. And this 0 to 3 is related to what? Z. So that's what I have written dz here. And 0 to 2 is related to y. So that's what I have written y. And this is 0 to 1 is related to x. So that's what the lastly I have written x. So all are constant limits. You can integrate anything first. Okay. So I'm going to integrate with respect to z. So xz, 2yz, and z cube by 3. The integral varies from 0 to 3 and dy dx as it is. Then you can apply the limit. Okay, right? So where we are applying in place of z. Okay, so 3 minus 0 is 3 only, so we are getting 3. And 3 y is 2y is a constant. If you apply z for limit, you will get 3. So you will get 3 2 is 6, 6y you will get. And 3 cube by 3. So 1 3 get cancelled. You will 3 square is remaining. So 3 square means 9. So dy dx. Again you are going to integrate with respect to y. So 3x with respect to y means you will get 3xy. And 6y with respect to y means you will get 6y square by 2. So that can be written as 3y square and plus 9y. So the limit varies from 0 to 2. Then you limit apply the limit. So if you apply the limit here, where we have to apply for y. Okay, 3x. If you apply here, you will get 2 minus 0 is 2. So 3 2s are 6x. And your uh, 2 square is 4. 4 minus 0 is 4. So 12 you will get. And 9 y minus means you will get 2 18. So 18 plus 12 is 30. Okay. Okay, next you can integrate with respect to x. So 6x square by 2. So that can be written as 3x square. Okay. And 30. And with respect to x means x. Okay. So then uh, you can apply the limit here. So if you apply the limit, what we will get? Sorry, 3. Okay. X square means if you apply the upper limit 1, 1 minus 0 is 1 only. So you will get 3 only plus 30, right? So 1 minus 0 is 1 only. 1 over 30 into 1 is 1. So finally what we will get? 33. So the final answer is 33. This is the way of evaluating the Gauss divergence theorem. Okay? Okay. Next, I go for the second problem. This is a similar kind of problem. So, in that previous means in the problem, in this problem, we have taken x is equal to 1, x is equal to 2, means 0 to 1, 0 to 2, 0 to 3 like that. Here we are taking 0 to a, 0 to a, 0 to a. Okay, the f value may be different. Okay, so here also the same thing. Divergent, first we should find out the divergent f value. So f is equal to what? X cube minus yz I and 2y x square j plus 2k. You see, this is the problem. Okay, I skipped the problem. Okay, evaluate by using the Gauss divergence theorem. This is the given function, and S is the surface bounded by the planes like this. Okay, so then uh, this is the f value. By using this f value, we have to find out the divergent of f value. Clear? So divergent of f is all are familiar. I think the sir has completed the vector calculus. So dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. F1 is this and f2 is minus 2y x square and z is 2, right? So divergent of f is equal to, if you are integrating this with respect to x, you will get 3x square, and here you will get 2x square. Differentiation of y is 1, and this is the constant, you are getting 0. So 3x square, if you subtract these two, you will get x square. So we are getting finally the divergent of f is x square. So our integral value, all the value varies from, means x, y, z, or values varies from 0 to a. I have taken here. And the divergent of f is x square. This dv is nothing but dx, dy, dz. Okay. In Green's theorem, dA stands for the dx and dy. In a Gauss divergence theorem, dv means in a double integral, right? In double integral and triple integral are not yet started, but in triple integral, dv stands for dx, dy, and dz. Okay. 0 to a, 0 to a, and 0 to this thing. And we are first I'm going to integrate with respect to z. So x square with respect to z means we will get x square z. Then I apply the limit, I'll get a square. Okay, yeah. Then I'm going to apply means I'm going to integrate the next one with respect to y. X square with respect to y means we'll get y 0 to 8 dx. Then again I'm going to apply the limit, I'll get a square. And I'm going to integrate with respect to x. So x square integration is x cube by 3. If I apply the limit here, you will get a cube by 3. Here a square is there. So if you multiply, you will get a to the power of 5 by 3. Okay. So this is the second problem. Next, we are going to integrate this next problem. Evaluate by using the Gauss divergence theorem. Okay. So this is the problem. This is the f function, and s is the total surface of the sphere. X square plus y square plus z square is equal to a square. Okay, first we should evaluate the divergent of f value. So f is what the given function this. So f is equal to this. So f1 is x cube, f2 is y cube, and f3 is z cube. So if I do like this, I'll get 3x square plus 3y square plus 3z square. Then all the three terms, 3 is the common. If I take outside 3 times of x square plus y square plus z square we will get. So here x square plus y square sphere equation is equal to a square. So that can be replaced by a square. So this can be written as 3a square. So triple integral under the volume V, divergent of f into dv is equal to the divergent of f is what, 3a square into dv under the volume V. So if I take 3a square outside, triple integral under the volume V into dv is nothing but the volume of the sphere. So volume of the sphere is, we know the standard formula for the volume of the sphere. So 4 by 3 pi r cube. So here the radius is a, so that's what I have taken a cube. You simplify this, finally we got 4 pi a to the power of 5. Okay, this is the way of evaluating the Gauss divergence theorem. Okay, clear? Okay, so I think this is the problems. These are the problems related to the evaluation of Gauss divergence theorem. Maybe next week the offline classes will start. So if it starts in the offline class, I'll go for the verification of Gauss divergence theorem. Okay. Suppose if not, so I'll go through the same kind of classes. Okay. And complete all the integral theorems notes. I have posted Green's theorem notes, and I will post this Gauss divergence also. When you come to the college, you come along with the notes. Okay. Okay. In college, I will not repeat these portions once again. Okay. Thank you. Thanks for listening.